All right, it's the time you've been waiting for, the final part of the three-part reactions. We did non-ionic, sometimes called molecular. We did the total ionic, sometimes called something else. We have not done the net. But to get to the net, we must go through the three different types of reactions. So we have this one, which most people feel happy about. It's actually the one that we're going to be using the most, okay? Then we have this one. People do not like the total. I do not like the total. That's where we have to break up everything that's aqueous. The net, kind of, for some people is like this. And for some people, it makes you feel really smart because it actually explains what's occurring in a reaction. Okay. So in order to get to the net, we've got to get through all three. Now, there are some shortcuts, which I'll go through at the very end. Okay. Non-ionic reaction for nitric acid reacting with copper to make copper 2 nitrate solution and hydrogen gas. So non-ionic reaction. Nitric acid, HNO3, okay, reacts with copper, Cu solid, and it will produce copper 2 nitrate. Whoa, copper 2 is 2 plus, nitrate is 1 negative, and hydrogen gas. Okay, now I left something out in the last couple lessons. I didn't want to overwhelm everybody, but acids that are strong are part of the aqueous substances that break up. Remember how I said aqueous substances break up? I didn't want to overwhelm everybody with that yesterday. So this is a really rare example where we have an acid. So strong acids, they're going to break up, and weak acids don't. I'm not too concerned. This doesn't really occur a lot until we get to Chem 30, but I just wanted to show you this one reaction. So you can always check your acid-base table. Anything above that gray bar, the hydrogens are going to split completely apart from the ion that the hydrogens are attached to. Okay, so in the total ionic, we have to balance this, right? I think we put a 2 there and we're good, right? Yeah. Okay, so now we're balanced. Total ionic shows all of the ions. Now, we have to break apart this one because it's aqueous, and with our new rule, we have to break apart the strong acid. So the hydrogen and the nitrate are going to separate. So we wind up with 2 hydrogen ions and 2 nitrate ions. Okay, so we're using kind of the Bronsted-Lowry, we're using the Arrhenius method to break this apart. Normally we would react that with water to make hydronium. This is just a shortcut. Okay, and we have copper. This has to break up based on rules of the aqueous substances to nitrates and hydrogen gas. Okay, now the net requires you to have a pretty good handle on what's happening in the total because the net shows what has changed. So entities that are the same on either side of the arrow, of the reactants and products that are identical, are taken out of the net. So can you see anything that's exactly the same? No, same state, same charge, right? So some of you might be thinking, what about the coppers are the same? Okay, true. But if we look, the copper has a different charge and the coppers have a different state. The entity that is exactly the same is the nitrates. And in the net, we actually remove them because they don't do anything. They're nitrates as a reactant and they're nitrates as a product. So they're actually called spectators. The nitrate ion in this reaction doesn't partake in the reaction. It doesn't change. And chemistry is all about change. So when we write the net, now if you're lazy, you could leave this exactly as is and then gently cross out the things that you need to remove. And this is both the total and the net together. If you want to rewrite it to be a little bit neater, okay, we get rid of the nitrate, I would do that. We're not going to make you guys work that hard on this stuff and do a million examples. Okay. So this is the net. This is actually what chemists care about in the reaction. It looks quite a bit different from if we go back to the non-ionic, right? Like they're very different looking reactions. The net reactions become really important in Chem 30. As I said, this is a skill to get you ready for Chem 30. When we move on to the rest of stoichiometry, 99% of the time, we are only going to be using the molecular or the non-ionic. Okay. Now, what's a shortcut? Well, if you wanted to go right from the non to the net, if you have a good handle on what to cancel out, you could say, all right, this is aqueous. Okay. Oh, wait, this is aqueous. This is a strong acid. That 2 means there's 2 of these guys. So I'm just going to cross out the nitrate, and I'm going to cross out these nitrates. Now, it gets you into some dangerous territory because when you rewrite it, look, you have to make sure you have the state and the charge of copper. And look, you have to make sure you have the state and the charge of the ion. But you can maybe see the writing on the wall before you get all the way down to the net. Now, that's living dangerously. Myself, I still write out the total just to make sure I don't make a mistake. Okay, let's try this one. Hydrochloric acid reacts with barium hydroxide in a neutralization reaction. Okay. Oh, there's an acid. Is that strong? Yeah, so we got to break that up. Okay, let's write out the non. Hydrochloric acid, HCl. Barium is 2 plus hydroxide is 1 negative. I think this is low solubility. It is. Okay. Neutralization reaction, remember, is like a fancy double replacement. So we get water. The hydrogen from the acid kicks out the barium, so we get HOH. And then the barium hooks up with the chloride. Okay, I'm pretty sure that's soluble. Just let me check my solubility chart. Okay, so barium, chloride, yeah, that's soluble, and the hydroxide is not. Okay, are we balanced? Answer is no. If we look, we've got 2 hydroxides here to only 1 hydroxide there. Putting a 2 there works. Now we don't have the same number of chlorides and hydrogens, so we put a 2 there. Okay, that's our non-ionic reaction. Now it's time to move on to the total. So we have to break apart aqueous substances and strong acids. 2 hydrogen ions plus 2 chloride ions. Leave that solid together. Barium hydroxide. Okay, water. Do we break apart water? No, we don't. Liquids, solids, and gases, and weak acids now don't break apart. So we leave that exactly as is. Oh, this one's aqueous. We have to break it apart. Okay, moving on to the net. So what is exactly the same on either sides of the reaction? There's only one entity, and that is the chloride ion. Those are our spectators, and we remove them for the net. So 2 hydrogen plus barium hydroxide gives us 2 water and barium ions. Now, those of you who were thinking about shortcuts before, maybe you saw the writing on the wall because you saw, okay, there's a 2 there, there's a chloride, and it's aqueous. There's a 2 there, there's a chloride, and it's aqueous. So probably maybe you saw ahead of time that that was the thing that was going to be removed. Our spectator is the chloride ion. Does not do anything to the reaction. Okay, one more. Lead acetate solution reacts with magnesium iodide solution. Oof, this is a double replacement. Okay, I'm going to cook along here. So we got lead acetate. Surprised that's soluble. Oh, it is. Okay. So we got 2 of those. Lead is 2 plus. Remember, I think we went through this yesterday. Lead is either 2 or 4, but 2 is the most common charge, and it doesn't give us the Roman numeral. So we assume it's 2. All right, and that's aqueous. You know, why am I putting it there? Shouldn't it go right here? Whoa! Ah! Fail. Okay, so we got lead acetate. 2 of these suckers, that's aqueous. Okay, magnesium iodide solution, MgI2. Double replacement. Okay, we get magnesium acetate. Right, magnesium is 2+, and that's very soluble. And then we get lead iodide. And lead iodide is not soluble, so that's PbI2 solid. And this is a nice one. I think it's all balanced, right? Yeah. So total, we got to bust apart everything that's aqueous. It's a big pain in the butt. 2 + 2 acetates. Okay, plus a magnesium. And then we have 2 iodides, right? So that's 2 separate iodide ions. Arrow. I'm going to bust apart this. We got magnesium ions. We have 2 acetate ions. And I'm going to, no, I can maybe sneak it in there. And then this is a solid. Okay. Whoa. All right. The net is everything that has changed. So what hasn't? Let's cancel out what hasn't. So this is aqueous. There's 2 of them. It's the same. Is there something else that's the same? Is there something else we can cancel? Yeah, the magnesium ions. There. So now we this one has 2 spectators. So we get Pb2 plus 2I negative gives us PbI2. Wow, that shortened it down quite a bit, right? Look, that's our net. Here is the whole reaction. So there's some stuff in the whole reaction that actually doesn't change. And for those of you who like the shortcuts, maybe you saw there's 2, there's this, it's aqueous, there's this, there's 2, there's aqueous. Okay, so that's probably going to go. And then maybe you saw there's magnesium, it's aqueous, magnesium, it's aqueous, so maybe that's going to go. Okay, but you have to make sure you don't make mistakes with your charges and you don't make mistakes with your states. So that's non-total net. The assignment you guys are going to work through is going to practice this stuff. Okay, and this is going to be a fluke hand-in. I posted it yesterday. It's due by Friday, or you have the weekend to work on it. We're going to start marking it on the weekend, though. Okay, all right. That is that.